to understand that, let's take a one instruction example. Let's assume a processor has only one instruction. We don't have all the instruction, it will be the same thing, but I'm just trying to show you with one instruction. And once I explain this, all the other instruction in the processor works the same way. So let's see that. Okay. Let us assume an imaginary high-level language called test. So somebody has developed a language called test. Okay, some creator. They don't look at the processor. No, these are created outside of the processor. It's designed. Okay, I'm going to create a language, created it, and put a set of instruction into that. So one of the instructions we are looking at is in the test language is called display. Okay, let's assume the creator has put an instruction into this language called display, and its purpose is to show whatever provided to it on the screen. For example, if you say display 5 or something like that, 5 has to come on the screen. If you say 5 display 4 into 3, it has to come as 12 on the screen. So the display command is a high level language command which is going to allow you to show something on the screen. You give whatever you want to say. It's a display and you say what you want to show, and that should come on the screen. So this is the purpose. Okay, this is the one instruction we are going to look at in this particular test language. So the test language has a instruction called display. Okay, this test language is a high level imaginary language. Okay, there is no such language like this. Just to explain this process, I am taking this language. Okay, so example, if we use the instruction display 4 plus 5 in this language, okay, in the test language, if you say display 4 plus 5, it should add these two and show it on the screen as 9. Okay, so this is what it has to do. So let's go through the process to understand how it happens. Let's take our original processor which we looked at in our low level language called processor A. This has add instruction, as you can go and refer back in your low level language video. Let's say, okay, so the processor is there, the high level language test is there. So now the test is going to give an instruction called high level in the test language. This instruction called display 4.5, 4 plus 5. Okay, 4 plus 5 is an instruction available in this language called test, which is a high level language. Okay, now if we give this instruction, can the processor understand? No, processor cannot understand. Processor understands only machine language. So let's see how this becomes possible. The person or the manufacturer or somebody who is very familiar with the processor A must write a translator. Okay, so we will write a translator to take this instruction and convert it into whatever instruction necessary to add the two things and show it on the screen. So let's see. Now this is again what we have seen earlier. So this 0011 is the add instruction in the processor A. Okay, this is 4 and this is 5, binary 4, binary 5. This is the code for add. Okay, right. So now what will this do? This will add the 4 and 5 and come up with 9. But these three instruction to the processor will understand, and it will add the two things and come up with 9. But in addition to that, this high level language also, this test high level language also wants it to show on the screen when you say display. So the display command, not only these three is fine to do the addition part, but display part also has to happen. So what will happen is this translator will translate this into add 4 and 5, plus it will put us another set of ones and zeros or instructions that the processor A can understand, which is to tell the processor, okay, this total value you display. So not only this, like in the assembly language, not only this goes into the conversion, this also gets this one automatically puts that also, because it has to get it displayed. So the person who is writing this knows, okay, in the high level language test, display 4 plus 5 means add the number as well as put it on the screen. So he will convert that instruction to this set, which will make the processor A do that, show it on the screen, add it and also show it on the screen. Okay, so again, like what we saw in the assembly language, these instructions get written into a file. Okay, now in our assembly language, only these three got written into the file. Now here, in addition to these three, the instruction which says to display on A also gets written into this file. This is a file in the secondary storage. So once this file is created, everything needed to add the two numbers and display is already here. So now we don't need this part anymore. I mean, we don't have to use that. Okay, we have used the converter or the translator and got it translated, and we have put it into a file. So from the file, you can take it and give it to the processor. The processor will work out 4 plus 5 as 9, and in addition to that, the display instructions, ones and zeros, that is necessary to do the display part. So with the help of all that, it will appear on the screen as 9. So if you look at it, this is why we say high level language is processor independent. It does not depend on the processor. See, this language used something called display 4 plus 5. Processor doesn't understand. So it's not dependent on the processor. But the translator is the main person who will convert this into the necessary codes to do that job. Okay, so because of the translate only, the high-level languages become processor independent. It does not depend on the processor because of the translator, because the translator will translate it to the processor dependent part. So once it is done, you can take it from here and give it to the processor. Processor knows these instructions. It will do that and the job will be done. Okay. So let's look at another example, this time with two processors to compare. Processor A and B. Again, two processors we used in our previous video in the the low-level language video. Okay. And we have a high-level, again, this test high-level language, and we are going to use a instruction called display 4 plus 5 this time. Okay. Now, again, as you know, high-level languages will not work on the processor, so you need the translators. So we have a translator for A, processor A, and we have a translator for processor B. These two softwares, that is these translators, would have been written by the manufacturer of A. Okay. Manufacturer of A will write the translator for A. Manufacturer of processor B will write the translator for B, because they only know what the instruction sets that are available here, processor B. Okay. Same way, A only knows what are the instruction sets available here. So they are the ones who know about this, must write this to translate it to the relevant commands. Okay. So now let's see this for display 4.5, 4 plus 5 in the high level language call test. We are going to give to both. Okay. Okay, this also takes it, this also. So now this translator and this translator will translate that. Now when they translate, notice this again from our previous video in the low level language. The processor A's add instruction is 4 zeros 1100. Okay, whereas processor B's add instruction is 410011. And this 4 and 5 is same on both. So when this translator translates the 4 plus 5, it will be translated like that. When this translator translates 4 plus 5, it will be translated like this, because this is what processor B will understand. This is what processor A will understand. So accordingly, each translator will translate according to that. So from this, you will understand whatever translated from this will not be able to use by this processor. Okay, the B's translation will not work on A and vice versa. That is, A's translation will not work on B. So A's one will work only on A, B's one will only work on B. Okay. So this is the add part in A, and this is the add part in the B. Now we have to have the display part now. So the display part commands required to do the display on this processor will be written here. The commands required to display on this processor will be written here. That's why I put a different set of ones and zeros here and different sets of ones and zeros here, just to show that the display is also not same. This processor's display commands to display or whatever that how the display process is done will be given by several. So this is just not one command. Okay, this is one command, this is one command, this is one data, this is one data, this is several data. Okay, you need all these several data to tell the processor to take this total and put it on the screen. So this is what that part is. On this processor, this is the part that does that. Tells the processor, okay, take this total and show it on the screen. Okay, right. Then both of these again, this processor will also write it into a text file, secondary storage file with these three commands plus this instruction here in the secondary storage, and in the B1 also these commands will be written plus the instruction to display on B will be written here. So once these are done, we don't actually require this, even whether they are there or not, it doesn't matter, because we will now be taking instruction from here. We will be running from here. So when you run here, this instruction will be taken, display 9, 4 plus 5 is 9, so this addition will be done here, and the display part is here, and it will go onto the screen. Same way, this is a different set of instructions also. From here, if you take and give it to this processor, that will again take display 9, because this will add up these two and come up with 9, this processor. This is the add instruction for this, okay. So this will come up with 9, and the display part is there, and it will be displayed on the screen as 9. So if you notice, we have two processors with two different add instructions, machine language level. But in the high level language, we are just using a common thing. So person who learns this high level language, whether they are using processor A or processor B, doesn't matter, as long as the translator for processor A is there on the processor A machine, and the translator for processor B is there on the processor B machine. So you write this and you translate it through A for this one and get it and run it there. So you have just written this command. So you don't have to learn the machine language version of each processor. The translator will take care of that. So that is how the processor, the high level languages become processor independent. It does not depend on the processor. Okay, the translator will do the necessary job for that. Okay, let's look